Reflections happen when light hits a surface and bounces back. Pool balls can be reflected too. Imagine you could follow the path of the white ball. A line drawn at right angles to the cushion is called the normal. The angle of incidence is the angle between the incident path of the pool ball and this line. The angle of reflection is the same as the angle of incidence. Sometimes light behaves like a particle. Other times it behaves as a wave. A ripple tank allows the reflection of waves to be studied in the lab. An automated dipper creates water waves which travel across the tank from left to right. A bright light shining through the waves casts shadows on the floor, forming a series of white and grey stripes. A closer look at the shadow of the metal plate in the tank shows the pattern of the reflecting waves. These are the wave fronts approaching the plate. The waves reflected from the plate have changed direction. As with the pool ball, the angle of incidence is the same as the angle of reflection. Some magic tricks are more obvious than others. The cocktail looks real enough, but where is it? Reflection of light can be used to create all kinds of illusions. From the top, you can see that the cocktail is carefully positioned at the side, out of sight of the audience. The magician's hands are behind a sheet of glass. The glass is placed diagonally across the stage and acts like a mirror. When a light shines on the cocktail, the light rays bounce off it. They hit the glass sheet and are reflected towards the audience. A virtual image appears on stage. Switch the light off and the image disappears. While theatres use reflection of light to create illusions, ships use the reflection of sound to measure the depth of the sea. The echo sounding system is called sonar. High-frequency sound waves, known as ultrasound, are sent downwards from a transmitter in the boat. The arrival of the reflected wave is detected. By knowing the speed at which sound waves travel through water and the time it takes for the reflection, the distance to the seabed can be calculated. The depth of the sea is represented on a computer screen. Each tiny dot is a fish, which has also reflected the sound waves back. Bats use ultrasound too. By emitting ultrasonic waves, they can judge how far away an object is, simply by the time it takes for the waves to bounce back. The reflection of ultrasound is also used in hospitals to create an image of an unborn child. It's a safe way of monitoring the baby's progress. Other waves can be reflected too. We rely on the reflection of radio and microwaves for worldwide communication. Satellites in space receive signals and reflect them back to Earth. These are collected by satellite dishes. But why are the dishes this shape? And why is the receiver positioned a short distance away? To see how a curved dish collects and focuses a beam, a heat source is placed some distance from a parabolic mirror. In front of the mirror are 3 matches in a row. But only the middle one ignites. The heat rays arrive at the curved surface and are reflected inwards. Wherever the rays strike, they all reflect to the same central point. This is the focal point of the dish.